something. Okay, anyway, welcome back MS-DOSX. Today is lecture 15. We're going to talk about table views and table view controllers. Specifically, this is going to be pretty specific to iOS. Mac also has table views, but they're a little bit different. Since Lion, they actually have a table view that's very much like iOS table views that use this view-based model. I won't go into any great detail about Mac ones, but there's this, just so you're aware, there is a different kind of table view that's available on Mac, and it shows there's another set of delegate protocols for you to implement, and just once you implement the delegate protocols, then you're all set. What are you? Okay. Whatever. Okay. Something's wrong with my version of Keynote. Anyway, so a table view, the idea is, at least on iOS, there's a single column and a bunch of rows. It scrolls vertically to scroll through all those different rows, and it's intended for fairly large data sets. So, the iPod application has a lot of songs in your library, most likely, and so you use a table view to scroll through all of those songs, scroll through all of your artists, depending on which page you're on in iPod. But the idea is that it's for fairly large data sets, and they appear all over the place on iOS. It's pretty rare to see an iOS app that does not have a table view in it somewhere. They are really powerful, really useful, and happen a lot, so it's really useful to know kind of how to play with them. So there are two flavors of table view. There is the grouped table view, which an example here is from the settings application, and even this is out of date, this is iOS 4, but beside the point, the idea is that your table view can have different groups, different sections, and in a group style, those different sections are visually separated by each other because they're all kind of grouped in a single bubble, and then there's space left between the different groups. On the other hand, we have the plain style. Ignore the fact that this is embedded inside of a nav view, inside of a tab bar, but there's a table here where each cell is just rectangular and fills up the entire width of the screen, and all the cells are pushed directly next to each other. So we have two flavors of table views, and you can use them interchangeably depending on what you want, how you want your UI to look. There are several parts to a table view, so I'm going to kind of go over for each style what the different parts are. A plain style will have a header up here. This is just some view property you can set on the table view. You just give it a view, and it shoves that view up at the top of the table. Similarly, there is a table footer, which again is just another UI view. You set the property, and it just stuffs that view at the bottom of the table. Tables are grouped into sections. Each section has a bunch of rows. And at the top, optionally at the top of each section is a header, which is just a text kind of to indicate a heading for that section. A great example of a header are, iPod and contacts and all those applications use the first letter of the alphabet because they're usually sorted alphabetically. So the first letter is shown in the header, so that way you can know what section of the table you're in without really having to, without needing a scroll indicator to indicate how far you've scrolled. You can kind of sense how far you're in based on what heading you're looking at. And similarly, there is also a footer that's going to be placed at the bottom of every section. So a group style is going to look pretty much the same. Again, you have a header that's up at the top, a footer that's at the bottom. Again, you're grouped into sections, but the section boundary is a little bit more fluid and less obvious because there's not these lines in between them. But you can kind of get a sense of where they are just based on the spacing. And again, there's a header, which is going to be some left-aligned text right above the section, and then there's going to be a footer, which is some center-aligned text at the bottom of the section. Okay, so now the question becomes, once we have a table view, how do we put data in it? What's the best way to provide data to this table view? And so the first idea you might have is, okay, let's make an array and store all the data in the array. Why might this be a problem? Does anybody have a guess why this might be a problem? Yeah. Yeah, what if you have a lot of data? What if you have 10 megabytes of data? Do you want to have a 10 megabyte array? Probably not. And the other problem is, if you have everything in an array, then that means that when you first load the table, you have to populate that entire array, and that could potentially take a very long time. So like I said, you have to keep the entire table in memory, and you have to load it all up at the beginning. So there's a pretty major efficiency hit if you have large data sets. The alternative is to use delegation. And fortunately, you guys are all experts at delegation now. Hopefully you've done that lab and saw really why it's so powerful. But the idea is that a table view is going to have some object that it's going to ask for data when it needs it. So in particular, it only needs to load the data for the cells that it's currently showing. It doesn't need to load the data for the cells that are 2,000 cells down below because they're not on screen right now. And again, this kind of solves both problems. We don't have to store the entire data set at once, and we don't have to load it all at the beginning. We just load the first 7 or so cells, however many show up on screen at the beginning. So there are 2 protocols to implement with regard to table view. UI table view data source and UI table view delegate, and I'll talk about those each in turn. The data source, there's kind of 3 pretty critical methods. There's number of sections in table view, which, as you would probably guess, returns how many sections your table view has. There's also number of rows in section, which returns, given a section number, how many rows should that section have. And then the last one that's really important is cell for row at index path. And ignoring what an index path is for the moment, but the idea is that this is, given a particular position of a cell, give me the cell that lives there. And so let's talk about what an index path is. An index path has been around long before there were table views, and it was used to index into arrays of arrays of arrays of arrays, rather than having to do array, object at index, object at index, object at index, object at index a bunch of times. You can actually, given an array, you can give a path of indices. So it'll the first index in that path will be the index of the outermost array, and then the innermost array, and then the innermost array. So that way you can really quickly drill down into nested arrays. And since we have cells within sections within a table, this kind of seems a natural analog to be able to use an index path to indicate where in a table view a particular cell lives. So they added a category to NS index path called index path for row in section. You give it a row number and a section number, and it generates an index path to get you to the cell at that row and section. And then similarly, there are properties, row and section, on index path for you to grab those back out. Does that make sense? So now we have a data structure so that we can specify very precisely what row number and what section number every cell in the table view belongs to. And that way we can identify, given an index path as a parameter, which cell we're talking about. So fortunately, this is something you usually don't have to worry about when you make a table view controller subclass. So the motivation for cell reuse is that if you're scrolling really, really quickly, it's probably not a good idea to allocate a bunch of cells and then deallocate them and allocate them, because there's a little bit of overhead in creating that memory. And if you're just scrolling past them really fast, there's really no need for you to completely destroy the cell, because you need another cell at the bottom. So they have this really clever technique where you can queue and dequeue cells that are, and it's actually really cool to see how this works. But as you start scrolling, cells that disappear off the top will get thrown into this reuse queue, and then you can just ask for a cell out of that queue, and you won't have to worry about allocating a cell. You already have a cell. Go crazy with it. Set it up. There's a little bit of overhead in kind of getting that started. Fortunately, when you build a table view controller, and I'll talk about what that is in a little bit, but it's a controller that manages a table view, as you probably would guess. But usually, it already provides this code for you that does all this. But the basic idea is you first try to dequeue a cell with some reuse identifier. If you only have one table and it doesn't really make a difference, it's just some constant string to identify what reuse group it belongs to. But the idea is you try to dequeue one, see if there's one in the queue that's available for me to use. If there is one, then cool. Then I just customize the cell with some text and then return it. Otherwise, I need to make a new one because there aren't any in the queue. So I can allocate one, and then TableView cell has a special initializer that takes, in addition to a frame rectangle to specify its location, it also takes a reuse identifier, and that way iOS automatically, as cells disappear off the top, throws them into the reuse queue. So you don't have to worry about how it manages that queue. It's all done totally automatically for you, and you'll notice that you can scroll very large table views very quickly because you're just recycling these cells, which is pretty nice. And the cool thing is, for the most part, it means that you keep about 7 cells in memory at once, instead of 1,000 potentially. Okay, so some other interesting methods on the data source. So you can specify. There's a method for setting what the footer for a particular section number is, and there's similarly one for each header for each section. If you want to be able to edit the table, to be able to delete cells from the table, to be able to reorder them, there are data source methods for that. So that way, every time you change the table in the UI, the data source knows to change its model, to delete the cell from the array it's maintaining, or rearrange the cells in the array it's maintaining, or whatever data structure you happen to be using. So that way you can make sure that that stays consistent with what's showing in the UI. Okay, so in addition to a data source, TableView also defines a delegate protocol, which allows you to customize not so much the data in the table, but what it looks like and how it behaves. Typically, this is the same object as the data source. It doesn't have to be. It would be a lot harder if they weren't, so usually it's almost always the case that they're the same object. And some interesting methods here. So there's will display cell for row at index path. So that gets called right before a cell is about to appear. So if you want to do some last-minute customization of what shows up in that cell, you can do it there. There's also will select row at index path. So that's right just as they're about to finish selection. So basically right when the touch comes down, that'll get called saying, okay, the user tapped this cell, what should I do? And then there's also did select row for when the selection actually completed. And we'll see in a little bit why the difference between those might be useful. So just a little word about selection in table views. According to Apple, cells in a table view should not use selection state to show some sort of state. That is that, at least on iPhone and iPod, cells very, very, very rarely stay selected, because usually selecting a cell causes some action to happen. In iPod, if you tap on an album, you don't see the album hidden, stay blue. It jumps you into the album and lists you the tracks on that album. On iPad, because you have a lot more screen real estate, they're actually able to show multiple views at the same time. So they often, for example, in Mail, will use the blue selection indicator to indicate which detail item is currently being shown in the larger view. And according to them, that's an appropriate use of keeping the selection state. But in general, and in either case, selecting a cell will cause some event to happen. It's just that on the iPhone and iPod, because you have a smaller screen, you usually can't afford to continue to show what you've selected. On iPad you can because you have more space. Okay, so it's sometimes useful to be able to disable selection on certain cells, and this is where will select row at index path comes in useful, because did select row at index path gets called after the selection has been completed and the user has finished tapping that cell. Will select row is kind of basically when the tap comes down. So if there's certain cells that you don't want to be selectable, but other cells you do want to be selectable, you can, instead of returning the index path that you're passed in, you can just return nil, saying, actually, I don't want them to touch that cell. Does that make sense? If, for some reason, you want every cell in your table view to not be selectable, there's a property on the table view that just allows you to disable selection entirely.
So if you returned a different index path, would it select a different cell?
Yes. Which is weird, but because I can't immediately think of a case where that would be useful. But potentially there is, I guess. Yeah. You could if you wanted. I don't know. I'm not sure what would happen. I mean, I imagine it would just send the did select to the one you return, as opposed to the one that got passed in. But this is a typical use case for it. It's just to disable selection in certain cells. Okay, so there is a view controller class called UI Table View Controller, which, as you hopefully can guess from now, is a controller that controls a table view. It automatically makes a table view on launch, so you don't have to worry about setting up the actual UI Table View instance. It creates it for you. And by default, a UI Table View controller is already a data source and delegate for a UI Table View. So for the most part, if you make a view controller, or table view controller instance, or subclass in Xcode, it will automatically provide bodies for pretty much all of the delegate and data source methods that are interesting, and then you just fill them in. And it handles some nice default behaviors, like look, the first time the table is shown, it loads all the cells that need to be on screen and that kind of thing. So just talking a little bit about what goes in a table cell. I think this is up to date. Used to be that you can set. It used to be that you could set the text on the cell directly. That property has been deprecated. But the idea is that cells by default have a image property, which appears on the left, and a text field that you can, or a text label that you can set the text of. So just some really simple properties that you can change what the image is in the cell and what the text is in the cell. Note, however, that UI table view cells are just views, so you can put whatever's view, because they're views, you can put subviews in them. So you can make these as arbitrarily complicated as you want. You can subclass them. You can have your own custom cell classes, which is pretty common, I think, to have your own custom cell classes and populate your table view with those cells rather than just straight UI table view cells. And like I said, they're cells, so you can do whatever you want with them. But Apple has provided some really the common use cases just to have some text and possibly an image in them. So that's for you out of the box. In addition to that image and that text, cells also have the ability to have some sort of accessory on the right-hand side. Those come in 3 flavors. There's the disclosure indicator, which is the one on the top, which is kind of this little chevron pointing to the right. Generally, the reason you use that is to indicate, okay, tapping on this is going to take me to another page. So that's pretty common. You'll see that iPod uses that all over the place. Settings uses that all over the place to indicate that tapping on this cell will take me to another page, usually by a navigation controller push. You can also have a detailed disclosure button if you want tapping on the cell to do one thing and you want to do some other thing based on. This is pretty much common when you want to do 2 things with a cell. The circular button kind of gives you more detail about the cell, whereas tapping on the cell does some action on that cell. And then lastly, there is a checkmark accessory. And this is kind of the canonical way to show state in a table view, is to just, the one that has state is the one that has a checkmark, rather than using the blue selection indicator. Because that one changes every time you tap, but this you can customize that as you want. Questions? Okay, and one sort of last parting remark on table views is that it's often very useful to have table views that have a custom row height based on some large bit of text. So here's some code that I want to give you guys to be able to do that, because it's a little bit of work. There is a data source method, height for row at index. No, actually, that's in the delegates because it's customizing the appearance. So I think this is a delegate method, height for row at index path, that given an index path tells you how tall that cell should be. And this could be, the default I believe is 44 pixels. But you can set up to some custom value if you want. The hard part is if you want that to be dynamic. And this especially becomes gross when you consider the fact that you're reusing cells. When cells get put into the reuse queue, they don't get like shrunk or resized. They just get left at whatever size they were before, which means that if you have dynamic size, you need to implement this, and so that way, whatever cell happens to be coming in, it gets sized correctly. So a common thing for this is suppose I'm populating from I have some array where I'm grabbing some strings from some value. It doesn't really matter where I'm getting it. There's a really handy method on NSString called size with font, constrained to size, and line break mode. That basically it's for this string with some font and some maximum width. How big of a text area do I need to fill that? And then you can just return the height of that, and then you put some text label in there that has that size, and put that text inside that text label. Any questions about how this code works? Yeah.
So is that kind of how like that is in the address book application, or you put in like a note or something that it will just grow?
Yeah. So I would imagine that the contacts application, because it has those variable length cells, probably overrides height for row at index path for those cells, and so that way the size of the cell can grow as the text inside the cell changes.
So is that called, as you type more, it actually will hyperrow, or is that's only when it calls hyperrow and index map, right?
Right. So when this gets called I believe it gets. I know for a fact it gets called every time you ask to reload the table. That definitely happens, and so they probably. I obviously don't know the implementation of contacts, but probably what they do is as you're typing, they just keep reloading the table to force it to make sure that the size is correct. But I don't know exactly. Good question. Okay, so that's it on table views. We are starting to wind down with what Glenn and I kind of consider the core concepts with iOS and Mac programming. We have one on user defaults and saving state on Thursday, and then Glenn has a performance lecture on Tuesday. And then after that, we have a bunch of sort of special topics of just cool frameworks and cool APIs to work with. And so I'm going to talk a little bit about each of those frameworks, and then I'll have a Google form for you guys to vote on which ones you want to see the most, so that way we can prioritize the ordering of those based on who wants to see all these frameworks the most. So there are 9 that I have in mind. They are listed here. We have core, and I'll talk about these in a slide, but we have core animation, core audio, core data, core location, core motion, Grand Central Dispatch, MapKit, UI, Message UI, and WebKit. And certainly if there's other ones that you are interested in, I'll leave a spot for that on the forum in case there's some other framework that you guys want to hear about. So in turn, the first one we have is core animation, which is this really great framework for doing graphics rendering, projections, animations, really complicated compositing effects, and it has this really great abstraction of layers that's very similar to the idea of views, but for you can composite layers. So you can see we have this this is Apple's example, this fairly complicated image where we have a bunch of views inside of here, and they all have this kind of border and this red shadow, and it's masked with an Apple logo, and it's composited over another image. And core animation makes all of this really easy to do, and it makes things really, really easy to animate, like a single line of code to animate things. It's pretty cool. Okay, so next we have core audio, which is a services for implementing some sort of audio and music features. So this includes recording, editing, playback, compression and decompression, MIDI, signal processing, audio synthesis. So this is kind of Apple's example of basically making your own movie studio, or not movie studio, sort of like a recording studio application, and it can do basically all of that. It's just pretty cool. Next we have core data, which is Apple's data modeling tool. It's sort of they offer it as an alternative to traditional databases like MySQL or Postgres. It's this great relational data modeling system, and from the docs they say it's generalized, automated solutions to common tasks associated with object lifecycle, graph management, and persistence. So it's a really great way if you have really large data sets to kind of manage all that data, and they have a pretty cool graphical editor for editing your data models. Okay, core location, as you can probably guess, is for the iPhone. It lets you get the location of the device. If the device has a compass, it also lets you get the heading. And then there's a set of APIs and a framework for doing that sort of thing. Core motion is a set of frameworks for accessing the accelerometer and the gyroscope if it's available on the device. So that way you can get very precise, especially if you have the gyroscope, positioning of the phone, getting the tilts, the yaw, and all those different rotation parameters to really precisely determine what direction your phone is facing. Next we have Grand Central Dispatch, which is this really cool framework that's been available since Snow Leopard to do really easy parallel programming. It abstracts away a lot of the hard work for you, so including things like thread creation, and you basically create a bunch of tasks and give these tasks to GCD, and it dispatches them and runs them on all the different cores in your machine, and it's really cool the way it just completely abstracts everything away from you. So you just say what you want to do, and it schedules them and figures out how to run them all in the machines to get the most power out of the machine you're working on. MapKit is a set of classes for including maps on your applications that allows you to annotate maps with things like map pins and other drawings on the map to indicate where things are. You can put overlays on these maps, and you can zoom and pan them, and do quite a bit more with them, with including maps on them. However, it doesn't include things like getting directions. You have to actually ask Google for that. But it has the ability to draw maps, which are served by Google. Okay, so the Message UI framework is a framework if you want to embed email or SMS or MMS right into your application, so that the user doesn't even have to go to the mail or messages application. You can just embed emails and SMSs right from within your application. These are pretty simple. There's just a view controller that you present, and it does all the work for you. You just make sure it knows how to go away. Last, we have WebKit, which, as you can probably guess, allows you to have web views in your application. And so it allows you to, it handles a lot of the overhead of handling HTTP requests, of processing all of the, client-side HTML, CSS, JavaScript, all that good stuff. It's all done inside of WebKit for you. So that way you just basically point it to a URL, and you have the web inside of your application. Any questions about these frameworks? Like I said, I'm going to have a survey up pretty soon, and so I'll have you guys pick like the three you most want to see, and then we'll prepare some quick lectures about these, so that way you guys can get a feel of, if you need these for your projects, we can kind of give you some direction of how to use them. Cool? Okay, we'll have a lab up in just a few minutes.